Okay, folks, if you're still with us, the next thing that we need to think about is what happens when we have two or more predictors in one criterion variable of interest. Isn't it possible that more than one predictor might actually influence or confound themselves? And so fortunately, we have partial and semi-partials to help us figure it out and clean the data up. And so a partial correlation is going to measure the relationship between two variables while controlling for the effect of a third variable. Whereas a semi-partial correlation is going to measure the relationship between two variables, controlling for the effect of a third variable on only one of the other variables. And so to give you an idea of what this would look like, we'll give you some examples here. So let's say that we were interested in a student's exam performance and the amount of anxiety that a student may have going into that exam. So in situation one, here at the top, you can see that exam anxiety is overlapping with exam performance, and the amount of shared variance between exam anxiety and exam performance was determined to be about 19.4%. So that means 19.4% of a student's exam performance is directly attributable or correlated with the amount of anxiety that they have on test day. But what happens when we answer another correlation, such as revision time? So let's say that we take some time to revise our notes, and we understand that the more time that you have to revise your study notes and prepare for that exam, that also impacts your exam performance. And so in number two, you can see that 15.7% of your exam performance is attributable to revision time. But where this concept really is reaffirmed and you can see the problems happens when you look at number three, where exam performance not only is overlapped by exam anxiety and revision time separately, but there's also components of revision time that overlap with exam anxiety. Well, that is not part of our research question, right? And so the fact that exam anxiety is overlapping with revision time limits the ability of both exam anxiety's effect on exam performance and revision's time on exam performance. And so the only way to really fix this is by calculating the partial and the semi-partial correlation coefficients. And effectively, what the concept represents is well defined with the schematic to the right of the slide here. And so if you were to look at a partial correlation, you can see that exam performance, revision, and anxiety is all statistically controlled, meaning that we can definitively determine how much of exam performance is overlapped by revision time, how much is overlapped with anxiety, and how much revision is overlapped with anxiety. And so we can calculate how much shared variance exists between them and cut out, so to speak, the bad parts. Whereas if you look at a semi-partial correlation coefficient, it's completely controlling the model such that you have unique shared variance between exam performance and anxiety and unique exam performance based off of revision time, which is what we wanted to try and establish to begin with. So the key to doing partials and semi-partial correlations is that when we have more than one predictor in our model, we need to be able to statistically control for other predictors that might influence each other and thereby influence the degree to which those predictors can correlate with our criterion variable of interest. The last thing I will then say before getting into the non-parametrics is that some researchers don't think that this is a problem at all, and they run something that's known as a zero-order correlation coefficient. And so a zero-order correlation coefficient assumes no control in the model. A partial correlation coefficient assumes some control in the model, and a semi-partial correlation coefficient assumes full control of the model. So I hope that's helpful. In the last video, we're going to go ahead and talk about what happens when we violate the basic assumptions of these tests, and we need to look towards non-parametric statistics. So we'll see you there. Okay, last video in the series, let's get into non-parametrics.